In topic 4.7, we're focusing on incoming solar radiation and the Earth seasons. We've already sort of talked about some of these things previously in the last several topics. This is also a review probably from earth science or other middle school science that you may have studied. But we know that many of the Earth's atmospheric processes, wind currents, ocean currents, weather, climate, are impacted to a large degree by incoming solar radiation, by the energy reaching the Earth from the sun. And a key factor in that is the angle of the sun's rays. The angle of the sun's rays as they strike the Earth's surface are really important. So if we imagine, for example, these are two diagrams that represent the northern hemisphere. So summer in the northern hemisphere is in June, starts in June. And during the summer solstice in the northern hemisphere in June is when the sun's rays are at their most intense. The sun is highest in the sky. The angle of that incoming solar radiation is as close to 90 degrees as it gets. And so the incoming solar radiation is focused on a relatively small area, leading to higher intensities of solar radiation at the surface. If we imagine when the sun is at a much lower angle in the winter, in December in the northern hemisphere, those same incoming solar radiation, as they reach the Earth's surface, because of that lower angle, they're spread out over a larger area, and therefore there's lower intensity of incoming solar radiation during those times, because those rays are spread out over a larger area. And we know that the highest intensity of solar radiation on Earth is received at the equator. And then as we move towards the poles, the intensity of solar radiation decreases. And there are seasonal variations as well. So the most intense solar radiation takes place on the longest summer day, on the summer solstice. The least amount of radiation received is on the shortest winter day. The winter solstice. And so we can see in this diagram what's going on in the orbit of the Earth around the sun. So first off, the angle of the tilt of the Earth is a key factor here. If we're thinking about the northern hemisphere, in June, the northern hemisphere, as we see here, is tilted toward the sun. And therefore, the sun's rays reach at a higher angle and are more intense. In the winter, the December solstice, in the northern hemisphere is tilted away from the sun. We can see that axis here, and therefore the sun's rays are spread out over a longer area at a much lower angle, and the intensity of solar radiation is less. And so those situations are reversed if we're thinking about the southern hemisphere. In December, the southern hemisphere is tilted towards the sun. And in June, the southern hemisphere is tilted away from the sun. And then at the equinoxes, we have neither the northern hemisphere are tilted towards or away. Okay, they are. That's when we have equal amounts of sunlight during those equinoxes. The length of daylight is also determined by the tilt of the axis and by the season as well. So if we imagine here, the sun is over here in this diagram. Sun's rays are striking the Earth. So if you think about this, the tilt of the Earth's axis, think about what season is this? In the northern hemisphere, this is summer. The northern hemisphere is tilted towards those incoming solar rays. Okay. And what we see, if you think about these places, let's think about the very northern latitudes here during the summer solstice. The Arctic Circle, as the Earth is rotating, the entire Arctic Circle up here stays inside of the sun's rays for the entire 24 hours. This is when there's 24 hours of daylight at the North Pole. And the same is true down at the South Pole. When the South Pole is tilted away from the sun's rays in the wintertime, then there's 24 hours of darkness. And as we move from north to south, we see that in our area, Around here, we have in the summer, when we are tilted towards the sun, we have longer periods of daylight and shorter periods of darkness. And then as the Earth continues its orbit around the sun, that changes. And the situation reverses in the winter. And we have our shortest day at the winter solstice, when we have the least amount of daylight. There's also these terms. The equator obviously is 0 degrees latitude. And then we have the tropics. In the northern hemisphere, we call it the Tropic of Cancer. It's at 23.5 degrees north latitude. The Tropic of Capricorn is the southern hemisphere line. And those lines at 23.5 north and south latitude are the areas in which the sun will be directly overhead. Okay. And so those are called the tropics. This zone, these are called the tropics. The tropical region is here. Just above and below those tropics are the subtropical regions, and then above that we have the temperate regions of the Earth.